Hey everyone, this is Ryan DeGregorio, host of Mind-Bending Astronomy. Thanks for joining me and welcome to today's episode. Last time we talked about Olber's paradox, which looks at the question, why is the night sky dark? Today, we're going to answer the question, why is the daytime sky bright? That is, what makes the sun shine? And it's actually a pretty complicated and interesting process. The sun isn't on fire, as some of you may guess, but instead it's exploding constantly. And so the sun isn't burning, it's not combusting like a flame would on a candle or in a campfire, because there's no oxygen in space. So we don't really have fire existing. However, we do have nuclear explosions. And that's really what's happening inside the core of the sun. Inside the core of the sun, where temperatures exceed 20 million degrees, protons are smashing into each other and creating helium, as well as releasing visible light. And this is a chain reaction that occurs when two hydrogen atoms come really close together because of the intense heat and pressure and fuse together to form a completely new element, in this case, helium. And those are the two main constituent gases that exist in the sun. And so you say, okay, well, it's just smashing protons together and releasing energy as light. That sounds pretty simple, but it's even more complex than that, because getting two protons to fuse together is an extremely difficult process. In fact, we've never been able to replicate that here on Earth. When two protons get really close to each other, they naturally repel, and that's because protons are positively charged. So if you put two of them together, they're going to want to move away from one another. So how do you combine them? Do you just heat up this furnace so hot that they have no choice? Well, kind of, but there's something really peculiar going on called quantum tunneling. Two protons don't have enough energy to smash together to form helium. But there is something that gives it a little loophole, and this takes advantage of the uncertainty principle. So we'll recap what that is. Uncertainty principle says that you can't exactly define the position and momentum of a subatomic particle with extreme accuracy. What that says is you can't pin down exactly where every proton in the sun is, and you can't say exactly how fast it's moving. Because of this uncertainty, there is a possibility that a proton doesn't exist in exactly where you think it is, but somewhere else. And so protons, when they're really not supposed to be touching each other, well, there is a very, 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 very tiny probability that they are. And in that case, fusion occurs. But this is such a rare occurrence. The probability that the proton isn't where we think it is. The sun is so enormous, it has so many protons in it, that fusion is actually pretty regular. And it happens a lot. It happens millions and billions of times, and that's why the sun is so energetic as it is. So join us next week for another mind-bending episode.